Next, in section 5.1, we have the example for the population of Youngstown, Ohio. Now, this is a city that may be experiencing population decline. So we know going into this problem that the B that we get is going to be less than 1. Population decline would be an exponential decay problem. So that B, when in our function y equals ab to the x, we know that B has to be lower than 1. So when we find the decay factor in part A here, the decay factor, what we're going to have to do is think back to finding that ratio, that common ratio B, by taking now divided by previous. So the more recent term here, 2007, is 73,818. We're going to divide that by the older one, the previous term, 80,764, and that'll give us the decay factor of 0.914. So 0.914 is the B in this problem. So I'm going to actually jump all the way down to part C right now and go ahead and write down the initial A, B to the X. The A would be the initial population in 2006. Let's find that up here, the population, 80,764. Our B, boom, 0.914 is your decay factor. That means that from year to year, Youngstown is retaining a population of 0.914, or they're retaining 91.4%. So the percent loss is the opposite of that. A couple ways to do this. The easiest way is to just take your 0.914 and subtract 1. We're going to see how far below 1 this number is, and it should come out to 0.086. Now convert that to a percentage by moving the decimal 2 places to the right. That's a loss of 8.6%. Think of it this way. If they're losing 8.6%, they are retaining 91.4%. If you add those two numbers together, you should get 100%. Next, in part D, what will the population be in 2018? Well, if 2006 is our base year, 2018 is 12 years later. So for this, we simply have to take 80,764 times 0.914 to the 12th power, because it's 12 years later. And you should get 27,452. Population of Youngstown in 2018. Now this last question wasn't on your paper, but it is on mine. How long would it take for it to reach 10,000? Look back to that last video, or to look at the 4 different ways to do a problem like this. You can either guess and check, you can use the table of values on your calculator, you can graph it, or you can use recursion. So go ahead and try that problem, and then answer the follow-up question. Do you think it's likely for this city to ever have a population that low? Certain factors to consider. Will this rate continue? Will Youngstown have a rebound? Will more people move there for some reason? So go ahead and think about that, and we'll discuss that tomorrow. If you have any other questions on 5.1's examples, let me know in class or by using the discussion blog.